LNUG number 103. We've been going since about 2011. We've built up quite a strong community behind us, and I think if you were around in 2011 and aware of the web, I mean, it was a different place then, and Node was in a different place then. I think people kind of measure how they got to Node through version numbers like 0.4 or something like that. And I think we've come a long way. I mean, we were in a dusty old sort of dirty hall in Hoxton somewhere. We brought along our own drinks, and you know, things have grown and grown since then into sort of, here we are with Cloudflare on the riverside, sort of, you know. This is how Node has changed and how we've all changed as a community as well. And we're more, but I think it's important to mention Node wouldn't have come this far without the people and the community and the culture that goes with it. And we're in a really sort of interesting and unique place in London because we still are a hub, despite all the changes in the world that have happened since 2011. People come through here for business, for travel. They like to share their ideas. People live here. They like to share their ideas. You can start something here. You can join something here. So it's all of our duty, really, to let that community carry on growing with the sort of spirit of people behind it, rather than just be guided by the technology or the choices that are made. This is my personal sort of feeling. So I'd like to invite you all to sort of join the community aspect of what we do here, help organize the next LNUG, give a talk, help mentor somebody who's learning to code in JavaScript and Node, and help them move up to the next level and help the ideas go forward. So that's just a little personal sort of feeling that I have around Node. I got involved with web development back in 1998, and I only felt I'd landed at home when I was like sort of in the Node and JavaScript community, because there was so much sharing going on. So we have a code of conduct, and that's just a standard. We're dedicated to providing a harassment-free meetup experience for everyone. We don't tolerate harassment of meetup participants in any form. The code of conduct applies to attendees, speakers, organizers at the monthly meetups and in related social events. And this includes slide decks, listings on the job board, and we'll go to the pub later. It includes that. If you do have a problem, please, organizers, just put up your hands. There's Thomas, who's in the corner there. There's Ahmed there, there's Akash there, or anybody from the hosts, or you can email us as well, or contact us at contact@lnug.org. I just want to emphasize that's a very important part of growing a strong culture. We have space on Twitter, and you can tweet about us, you can mention us, you can contact us there. It's a good way of contacting us. And you can contact me as well if you really want. Right, we've talked about Cloudflare. We are here, you've found it, so welcome to Cloudflare. Thanks again to Cloudflare for hosting us. I hope we have many more meetups here. And thank you, of course, for the real reason we're here, which is beer and pizza. So yeah, a round of applause for Cloudflare. We have a large, if you go to our website, we've got going back over 10 years, 13 years, a history of talks on Node.js over the years. We don't have every talk ever given because we didn't think to keep them all at the time. And recording what we do here, recording the speakers has always been an important part of what we do, and we keep that, and we keep a history of that. And Alex has been filming for us for, I don't know, 7 years. He was previously helped by a business member of our community in Pusher. Pusher are no longer doing that, so Alex has come along still to help us do this, and we're really, really, really happy to have him along as part of our community. It's a very important part of our meetup and how it runs and keeps it ticking over in a way, in the practical sense. If you're organizing an event at work, enterprise, corporate, and needs filming, get in touch with Alex, because he will do a brilliant job. So yeah, and thanks Ahmed. Okay, I'm going to leave this for the intermission, right? We always have space for you to introduce yourself. Some of you, your names are known in public already. But if you're hiring, if you have an open source project that you're working on, something that you'd like to share with the community here, and get talking face-to-face, because face-to-face is really a lot more meaningful than Zoom, then we will give you a little space at the end of the first talk. we'll have an open mic session. You'll have 2 minutes just to address the crowd, and then you can break off. We'll have a little break, and you can continue the conversation there. So if you have anything, think about it during the talk, and then come and speak to me. I'm nearly done, all right. And then first talk, Piers is waiting there. He's like, I've talked about the community, getting involved. We have various forums for contributing and giving us feedback. Hey, Clement's just walked in. Hey, Clement. So we do a lot of it on GitHub. So please give us feedback there, or submit a talk proposal. Honestly, if you've got a war story to tell from the trenches of JavaScript development, we'd want to hear about that. Give it a bit of a story spin. We can help you shape your talk. If you're thinking of doing something bigger and going on to do conference speaking, the meetups are a great place to practice and start your talks. So come and speak to me about that, or go straight to the speakers repo and create an issue there as a proposal, and we can take it from there. Really urge anyone from any level to talk about their experiences, because at a human level, it's always interesting, and I think we can all relate to that. And a good talk is always on a storytelling level is always very interesting, as well as on a technical level about Node. So. Think about that as well. There are lots of ways to contribute. Piers, TypeScript all the way down.
Okay, so so I'm going to talk about. I had to come up with a title for this, and we kind of went with TypeScript all the way down. If any of you read any of the Terry Pratchett Discord books, you have kind of like Turtles all the way down. That's kind of where it's from. So that's quite an old photo of me, actually, but it's about the best one I have at the moment, so deal with it. So I'm Piers. I'm a senior solutions engineer at Pulumi. We did sponsor one of these last year, I think it was. But yeah, that's me, various ways of contact. So if you don't know what Pulumi is infrastructure as code. The idea is that you can use any language you want within reason to kind of deploy your infrastructure. Pulumi is open source. The idea being that we want to help as many people as possible to kind of manage their infrastructure. There is a commercial aspect to it, but everything I'm going to show you today here, you can do for free. And so, yeah. The idea being that you can deploy to whichever the clouds you want using a language, standard sort of tooling, things like that. So the TypeScript bit comes around. So we've had for a long time this idea of full stack developers, where the traditional kind of pre-cloud apps, when you had just a website and a back end, and the full stack developers were there to they did the front end, they did the back end. There may have been kind of some kind of database there as well. And you either did one or the other. You either were front end or back end or the full stack. And there might have been some kind of infrastructure management stuff in there as well. Maybe you managed a Linux box or a MySQL database, something like that. But as TypeScript has grown, as the cloud has come into play, we've kind of now got this aspect of what I call the full stack plus developer. Because we had Terraform for a long time, and then along came Pulumi, and then CDK and CDKTF, and all these tools now allow you to kind of use similar, the same or similar languages to the ones you're actually using to write code. And I think that's a really important thing, because it means, often when you're working in tech, when you're programming, you talk about being in the zone, in the matrix, you're concentrating on what you're doing, you're writing your code, no one's disturbing, you've got your headphones on, that kind of thing. And if you are the sort of person that is managing some infrastructure or doing something like that, and you have to switch to either sort of YAML or HCL if you're using Terraform, or CloudFormation for an AWS, and those kind of tools, it kind of takes you out of the zone. You're doing something different. The syntax is different. Even if the code you're writing is something like Rust or Perl or Ruby, you're still kind of taken out of that zone. And by using some of these tools, Pulumi, CDK, CDKTF, it means you can kind of use that same language all the way down. And that's where that idea comes from. It also means that you can integrate your infrastructure as code workflows into your application. So, for example, Pulumi, and I'll show you a quick demo of this later. The idea is you can actually make your infrastructure, part of your application. You can actually make changes based on things that happen. And what that also means you can then kind of use the same tooling. You've got your IDEs. I mean, use things like Visual Studio Code, various tools from JetBrains, Visual Studio if you're using the .NET kind of sort of stuff. And there's no point in kind of jumping around. You want the same sort of syntax highlighting. You want the same the ability to write the same code that you're doing in your normal job, because I'm sure very few people here are like me and actually just do infrastructure all day, every day. You're writing code, you're building applications. Why would you want to break away from that? That's what you do for a job. Let's kind of extend that part of it and allow you to do the infrastructure. You have the same testing frameworks. If you're using TypeScript, use Jest or Mocha, Chai, those kind of frameworks. .NET, you use XUnit. It's all about kind of using the same tooling that you've been using for years. I've been doing this stuff for too long, and as a result of that, there are certain tools that I like. I use VS Code every day. It's the tool I like doing it. But that means that I can use that, and I have all the same syntax management, testing frameworks, package management, and all those same processes. So because you're writing software, which is effectively what you're doing, you can then use that to kind of build out your, the same process you go through when you build your applications. Let's create PRs. Let's go through that kind of merge request, that process, and actually make sure our infrastructure is safe and secure because we've got the tests there, because we've got, policies being run against the infrastructure we're trying to build, that kind of thing, and actually make it that all the infrastructure we're pushing out and all those changes we're making are safe and secure. And the thing is, the time to ramp up is really important. Just had a question here. How many people, and this is probably going to be really, really bad, how many people do some sort of infrastructure as code as part of their job? You do CDK, you do Terraform. No one's going to put their hand up, are they? Anyone? Oh, okay, that's cool. So you at least know about these sort of tools. And out of those people, how many are, that is not their day job? Their normal day job is building applications. They write software for a living. Yeah? Yeah. So presumably, and I'm going to guess that a majority of you also use Terraform or HCL, something like that. And so when you started building applications, you're doing one language, probably JavaScript or TypeScript because you're here. And then you've got to sort of learn the HCL part of it as well. Well, what's the point in learning a whole new thing when you can just use CDK, use Pulumi? You already know these languages. There's not much point in kind of learning these new things, new way of doing things. And the same thing kind of goes for things like community and jobs out there. How many TypeScript developers do we think there are in the world? There's millions. I bet there's not as many people that know things like HCL, things like CloudFormation, all those kind of things. I bet the number's far fewer. So why not kind of look at building out your CV and that kind of thing, because you're still using those same languages. There's no point hiring someone who knows, HCL when you can hire someone that knows TypeScript, because that's the application they do. That's the language they write the applications in. Let's make that the language they write their infrastructure in. Infrastructure library. So Pulumi, we have component resources. CDK, you have constructs. If you've not used either of those but know Terraform, it's a Terraform module. The idea being that you can build out infrastructure libraries, you can build out NPM packages, NuGet packages, all those kind of things, put them into whatever Artifactory type thing that you use as a day-to-day, and you can actually start building out SDKs and as I say, these infrastructure libraries based on the code you're using. And it means you can have these shareable libraries. So you've done someone has done the work to actually create these libraries. And then you can share them and make it easier for people to kind of build and deploy their applications more easily. And then you have this idea of embedding your infrastructure. This is more of a Pulumi-related thing, where you can actually embed your infrastructure and the changes to your infrastructure into your applications. So you end up with infrastructure as code tooling that reacts to external events. So for example, you could have like a REST API that receives requests, or some like sort of pub sub queuing system that receives events, and then you can trigger changes to your infrastructure based on those events. So let's say you want to, let's say you sell web servers. You sell web servers, and someone puts a credit card in. Credit card is all good, and then that fires off an event, and because of that event, you can then start creating all the web servers they need to run their application. And it's all integrated, and it's all automated, and because it's automated, it's relatively safe. And so, yeah, you kind of get these things that, as I say, react to external events. I have no idea what time I started. Cool, okay, so I'm going to show you what this looks like. This is Pulumi. As I say, you can do all this stuff for free. I'm using air quotes here, Monorepo, because it's nothing like what the next talk is about, but everything's in one repo, so yeah. So this is kind of, has anyone used Pulumi? I know there was one guy here before who has. Nice, love it. Okay, that's more than I expected, so that's good. We're still a startup and so forth. So this is what Pulumi looks like. Obviously, this is TypeScript. And the idea here is that you can, you're defining your resources. Everything is dependent on each other. You're using, what is more kind of Node than that? Grabbing something from the file system, and actually kind of building out these resources. And it's fast as well, because you're kind of not using. Although there is like state and stuff like that, it's TypeScript, it's fast. And you can kind of set up, you can have all these programs working together. So I've got this. I'm going to quickly run this. No, that's not right. Where is it? Backend. I can't spell, I'm sorry. Okay, so that's coming up. So I've got my application already set up. This is going to allow me to deploy a database. So this is my backend. There's nothing, there's nothing unusual about this. I'm deploying a Hono app because we're at Cloudflare. If anyone hasn't tried Hono, it's really, really fast, and I really, really like it. I don't work for Cloudflare, obviously. But I really like it. Although I do not like Wrangler. If anyone, if anyone, I heard some giggles. If anyone kind of has used this, just let me do stuff in infrastructure as code. Don't make me run other tools. I've just spun up, in the time it's taken me to talk, I've spun up a database, and various things for this to run. So that's fast. I could combine all these things together. I can actually turn this into a TypeScript class, and then I could put that in an npm package and go have some nice defaults and go, here we go. Now you can all deploy a worker script, a Cloudflare worker, pass in the path of your app, and that'll allow you to do it. And so you don't have to come up with anything extra. On top of that, you can just deploy it. And as I say, it's all very simple. It's all very nice. Front end is exactly the same, except for this is Cloudflare pages, so it's all Git based. But again, and the nice thing about this is you can actually run code as part of your updates. So because I've already got my code in a repo, if I create a pages project using Pulumi, it will create the pages project, but it won't trigger a first deployment, because usually if you go through the workflow, you select your GitHub repo and it starts deploying straight away, but it doesn't do that if you use the APIs. However, because you're using Pulumi, and this is one of the nice things about it, you'll notice here I'm actually making web requests as part of my update. So if I run Pulumi up here, which is how I deploy stuff, once these things are there, so I've got my pages project name, my pages domain ID, which means that those resources have been created, it's then going to run this API call. And so that allows me to kind of build out, to actually start integrating with the Cloudflare API even if there's not a specific resource to do the thing I want to do, I can start kind of playing around with actually make API calls as part of my update, which allows me to kind of expand on what's already there. Yeah, so I'm going to run that. What's that? Front end info. And that's going to run, and that's just going to run. No, it's not, because I can't even spell the place I work for. Yeah, so that's going to run now, and that's going to start, and that's going to deploy very quickly. And it's going to, because I've got that API call in there, that's just going to, once these other resources have been deployed, that's then going to go and run this API call. And we'll see that in a second. The other thing that you might notice is, and this is a nice thing, so I've got my Cloudflare token and I've got my Cloudflare account ID. So I've actually also got a third project here called Setup, which I have before. Now, I'm going to show you now all my Cloudflare details. And you can take photos of the screen, I don't care, because it's all encrypted, so good luck with that. So if you've used Terraform and you have secrets in Terraform, they're not secret. Rule number 1 of using Terraform State, any secrets in there, they're not encrypted. As you can see, we encrypt stuff, so that means that I can now share that with other projects in my infrastructure, and it will decrypt and encrypt and do everything magic it needs to do to be able to do that. And as you can see, while I've been talking, the rest has been deployed. So if I go to here, where are we? Yeah. So you can see I've got the back end. I've got my data store, which doesn't have any tables because I haven't run the migration script yet, because Wrangler. And I've got my Cloudflare pages, and you can see here I've kicked off the first. It's already been deployed. And that's all through that API call. It means that I can do extra steps around. So another example is, I've got some extra configuration in some database somewhere. It might be another D1 database, I don't know. I can go off and make calls to that and actually grab config from those data stores and actually use that configuration as part of my setup, all because I am using an actual programming language and I'm not, with CDK, CDKTF, you're not running the actual TypeScript that you write. You're running the kind of the transpiled. CDK goes to CloudFormation, CKTF goes to JSON that is the compiled version of HCL, and so you can't. There's a lot of things like this you can't do. I'm sorry, this is starting to be a bit salesy. I'm listening to myself, but it is a matter of fact. There are things you can do with Pulumi you can't do with other tooling. Yeah, and so I've got this now. Has it set up my? Has it actually set up my thing? It says this works. So there we go. So that's what I've deployed. If you want to go to that URL, you can. It's not gonna break anything. But yeah, so that's kind of and that's all been done with TypeScript. There's been no kind of other languages. I've not compiled anything to other languages. It's pure TypeScript, pure code, and it means that I'm not a TypeScript developer. I'm not a Node developer by default. My background is .NET, so I'm not going to show you the actual code for this site because that would just be embarrassing. But if I can, as someone who uses .NET, who uses TypeScript, this makes it easier to kind of manage your infrastructure because you're using languages. Even if you're not using Pulumi, even if you're using CDK or CDKTF, it's worth investigating those because it means that you don't have to break out of the zone. You don't have to context switch. All those kind of buzzwords that you hear when people talk about how developers can really focus. You don't have to kind of change that because you're writing in whatever language your application writes in. Yeah, that's me done. If anyone has questions, feel free to ask. Otherwise, I'll be hovering around later. It will be. please don't judge me on the code because it's not nice. Yeah. Sorry, the GitHub name is my name, so it's the same as.
This isn't exactly a question, but I just wanted to ask about your opinion on like SST Ion, because I know they're using Pulumi as well. So just wanted to know your thoughts on it.
I love it. Like, we've been working closely with those guys. Dax and
Jay?
Yes, that's the one. So they've been part of our, we've been working with, they're in our Slack workspace. We've been working with them, and it's great. And I am biased. I've been working at Pulumi for the last 3.5 years, been using Pulumi for about 4.5 years. I'm biased. I wouldn't work for Pulumi. I work in sales, literally. I wouldn't be able to sell something that I'm not passionate about, like as I am as passionate about Pulumi. And I love that they're using Pulumi, and it shows how extendable it is, because the code they've written is all in Go. All the stuff they've written is in Go, but if you go and look at SST, none of it is in Go. It's all TypeScript. And that shows the extensibility, the power of Pulumi, that you can actually do that, and you can kind of work with the different languages and things like that. I think it's going to be great. It's going to be great for us because even if you're still using open source version, it's getting the name of Pulumi out. HashiCorp have a long, they have years ahead of us. And so, it is the case that I think it's great. I think it's a great tool. I think that it's going to do, if it helps people learn about Pulumi, and if it helps people build better infrastructure and better but safer infrastructure, that's all good as well.
Thank you.
Any more questions?
Thanks, Piers. Great talk. What's the local dev story like with Pulumi and workers? Because I know Wrangler's got a great local dev mode, but how?
So I would say that because Pulumi is not really the thing you're running, the idea of Pulumi is that you end up with something in a remote place. You can run, as I mentioned earlier, there are ways of embedding Pulumi into your application, and obviously that is an application you're running on a local machine. So that is just a Node app or whatever. But because the thing you're talking to is remote, there isn't really a local story. Like SST is going to do wonders for things like running and testing lambdas more easily and things like that. At the end of the day, they're still using Pulumi, they're still using Amazon, so there's still going to be that kind of latency, that feedback loop is still going to be a bit slower. But I would say there isn't really one, because it's not. You can test what you're doing in Pulumi, so you can run unit tests against it. You can also run, we have this thing, policy as code, which means you can actually build out policies using OPA or TypeScript or Python to actually almost test what you're doing and make sure what you're doing is actually safe and secure. So don't open port whatever to the internet, that kind of thing. So there is a local testing story, but there isn't a local running story because you're not running Amazon from your laptop. You can use it with a local stack, but you're not running AWS from your laptop, so you wouldn't be testing against your laptop.
Thank you.
Oh.
I can shout.
Okay, so quick question on Pulumi. So what's free and what do you have to pay for?
That's an excellent question. Okay, so as I said, so Pulumi is open source. The CLI is open source. So there's kind of 3 parts to it. So you have the CLI, you have the providers, which are the bits that, so like Terraform has providers, we have providers, use them to talk to whatever cloud service you're using. And then the state storage. So you can store your state in S3, an S3 bucket, in Azure Blob containers, on your local laptop, and you never have to pay us a penny. There is also a commercial SaaS product where you can do state storage and do, control who has access to what what deployments and things like that. That's the paid for product. The rest is the CLI, the providers. That's all open source and free, and yeah.
Cool. I think we're going to call time on it. If there's more you want to talk to Piers about, we'll be having a break for about 10 minutes in a minute. So yeah, thanks, Piers. Get to give him another. It's now time for anyone who has, remember I mentioned earlier community announcements. I know there are a couple, so if you want to just put your hand up now if you've got anything to say. We've got one. Anyone else? Anyone else? Okay, there's one. So we'll go into it.
Yep. Yeah. Okay, all raise your hand if you consider yourself at least a mid-level Node backender. Only one? No, come on. Why are you coming to this meetup? I was expecting some more. Keep your hand raised if you think you're pretty good also with Postgres. This side is too shy. I don't know what's happening in this side of the room, but okay. Okay, cool. A client of mine is looking for your kind of profile. It would be nice to have a bit of Go, a bit of full stack, but again, the really core part is to be at least a solid mid Node.js plus Postgres. Can talk to me during, is an edutech, is a startup, but is a nice environment, is hybrid. 2 days negotiable in the office. We already have 250,000 students, so things are going pretty nicely. Whatever other question you might have about this role, let me know.
Cool, thank you. Just a show of hands, how many people here have found their job through LNUG? Because I know it's true that they have.
But not the correct one.
Well, my current one. Thomas, put your hand up. You found it. No, maybe not your current job, but you found a job through LNUG. Yeah, who found the job through LNUG? Yeah, yeah. So it's a great forum here to find work. We'll keep that conversation going over the months. We used to hold more of a jobs forum in the intermission and in the break. So if you know people who are hiring, or if you're looking to get hired, or just if you know people who are looking to get hired, bring them along to the next LNUG, and hopefully we can get people in touch with each other, talking really face-to-face, and that's what we like. Okay, we're going to break now for about 10 minutes before the next talk. Don't go anywhere, grab a drink. If there's any more pizza, I'm not sure if there's any of that. Did you want to have a quick?
So my company, we are also hiring in case if someone finds me, connect with me as well. Yeah.
Right. Anyone looking for work? You got people to talk to. Enjoy the break. Right, so we're ready for part 2, and we have a surprise. A surprise is Sid. Sid's going to give us a quick lightning talk. I have no idea what it's about. What's it about? He doesn't know what it's about. Is it about JavaScript and Node? A little bit about JavaScript and Node, so at least he's come to the right meetup. Big round of applause. This is what we like. A bit of a surprise.
All right. I like lightning talks because there's no fluff, is there? I have no slides. We're going to look at code. My name is Sid. I work at Cloudflare in this building. I've been here for about 2 years. I worked on workers, pages, a bunch of stuff at Cloudflare. Lately, I've been building something new. That's what I'm going to show you. I don't think I've shown this publicly yet. There's been a blog post announcement. This might be the first one. So let's get right into it. It's super alpha. It might not work. Fingers crossed, I guess. Anyway, how many of you have used ingest or temporal or Apache Airflow back in the day? 1 person in the room. 3, 4 people in the room. Holy crap. Okay, let's start from the top then. All right, all the way from the back. When you have long-running tasks that you need to do, typically they are hard. They're hard because when we all do a fetch call in Node.js or on the web, we expect it to just work. That doesn't happen, right? Network fails, I/O fails, all sorts of things fail, connections break, DNS doesn't get resolved, a connection, packets get lost, etc., etc. Reliability over distributed systems is a hard problem. Right, more often than not, if you're writing services, if you're writing a lot of little services that do a lot of work together, you've probably built in retries yourself. I'm sure all of you have done that at some point, right? You've probably used queues to be able to queue or batch jobs that need to happen out of band of the request. So far at Cloudflare, right, we've had the only compute sort of the only compute product, so to speak, that we've had has been Workers. How many of you have used Workers? Okay, that's great. So a lot of you are familiar with Workers and how we run JavaScript on the edge. It's just V8 isolates, really. In fact, we even have Node.js Compat now. We're sort of working towards it, right? But as you all know, most likely, Workers are meant for short-lived requests. They don't last very long, you know. They can. I mean, if you're on an enterprise plan or whatever, you get unlimited wall time and about maybe 10 or 20 seconds of CPU time. But 10 or 20 seconds of CPU time is not a long time. If you want to run any kind of sort of background task like transforming videos or generating a bunch of images, or lately AI is all the hype. If you want to generate embeddings for a RAG, how many of you know what a RAG is? Oh, wow. People love AI, don't they? All right. So RAGs, typically, for the ones who don't know, are a way to take an AI model and give it context about your own data, right? You have your own internal wiki pages or your PDFs. You sort of give the AI context about it. So you can now chat with the AI about stuff that only you know in those documents that isn't sort of publicly available. RAGs are really painful to build as well, because most AI systems today, because of how young they are flaky, right? We're going to build a RAG today. In fact, I've already built it. We'll pretend like we're going to build a RAG today. And I'm going to write a quick sort of demo for you today live as well. The product that I'm going to show you is, we're calling it Workflows. I've been building workflows for about, I want to say about 10 weeks, give or take now. It hasn't been very long, very early days. But let's just jump straight into what a workflow is, all right? So I have this workflow demo here. A lot of these types will change because obviously we're just sort of building. Is that visible? How is that too small, too large? How are you feeling about that? Yeah? Too large? All right, okay, all right, sure. If you say so. All right, so what this is doing, now pretend that a lot of types are different because, like you know, early products, things change. But the core idea here is that you write a class, right? Just like you write a class in JavaScript. We're not reinventing a programming language here. But you extend something called, today it's called worker entry point. Tomorrow it'll likely be called workflow once you've sort of figured that out. And you write a function called async workflow in there. Within that function, what you can do is you can separate your code into a bunch of closures. Now, each of these closures, as you can see, are being passed into something called a step.run function. Right? This might look familiar if you've played with a lot of these tools lately, like ingest and so on. And I think the goal here is that it ought to look familiar. We don't want to reinvent wheels. But what do they do for the ones who haven't played with them? Step.run will atomically run all your code in that step. If anything fails, it'll roll back. We're tracking all I/O, all sub-requests, all compute that runs within that closure. We're able to roll it back if there's an error thrown within there. All right, so think about step.run as a database transaction, but for your code. It'll automatically retry. There's same defaults here, but if you want to override them, you can pass in an object with retries set to a limit of 10, with a delay set to, not a delat, a delay set to 1 minute, and back off set to, you can do constant, linear, or even exponential. In fact, I believe this is the default, if I remember correctly. But you can override them. Now, the idea here is that you don't have to think about these things. Retries happen automatically. If you have a bunch of events coming in, and based on your batching settings for your workflow, you can automatically batch them in the sense that the workflow will run once for every 10 or 15 events as opposed to once for each, right? You can even do something, well, called sleep. Now, this isn't a micro task sort of this isn't a set timeout under the hood, right? You'd expect this to I mean, everyone's written a sleep function. The way you typically write a sleep function is that you wrap a promise and you set a set timeout and you pass a closure that calls resolve eventually, right? That's how you typically write a sleep function. This isn't that. This is pausing all execution for you, right? So you don't get billed for the time that the sleep is going on, which is why it doesn't just have to be 5,000 milliseconds. You could sleep for a year. And that works, shockingly, right? You could sleep for a year, you could sleep for 30 days. The typical use case for something like that is, subscriptions. You can subscribe and charge a card every 30 days. And you can co-locate all of that code by literally saying charge card, sleep, trigger again, right? All of this without having to think about things like queues or event primitives under the hood. In fact, one more thing before I actually run this demo that I'll show you, is that you can even do this. You can even say that you want to wait for an event specifically. So imagine if you had, and I believe this takes a type and a name and a bunch of other crap. I actually haven't built this yet. But imagine if you have an R2 bucket where something gets, constantly, uploaded. Or if you have a dashboard where some chap has to literally click a button, that's okay, but you can just wait arbitrarily for some other side effect to occur and pause execution till there. These are really interesting primitives, and they sort of flip how we think about writing, business logic. You're no longer thinking in queues and database rows and like low-level primitives, but you're sort of thinking in steps and events and so on, right? Let's try running this and see if it actually works. The way to deploy these is actually quite simple. You can call Wrangler workflows deploy. This is not publicly available yet. There isn't even a closed beta. There's nothing. It's just on my machine. Actually, that's a lie. It's very much on the edge. But there will be a closed beta shortly, in a few weeks, not months. I've already deployed this. I won't bother you with that time because we're running short of time. But I will trigger an instance for you. And what triggering an instance looks. And please don't steal my bearer token. It's somewhere in here. Oh, it's in a different tab. Okay, cool. That's fine. Don't pay attention to any of the UUIDs. But the way you trigger a workflow is it's similar to a worker where you create requests. You trigger instances of a workflow. We're going to trigger a new instance today, right now. So if you list instances for this chap called LNUG demo, which I just deployed right now, you'll see that the status is complete. It was created roughly about maybe 4 or 5 minutes ago. This is UTC time, which is why it's an hour prior. I'm going to create a new instance of it. Now, by the way, what this workflow does is very trivial. It calls this thing called webhook.site, which is a very cheap way to get someone to show me that an API call happened, right? It looks like this. It basically tells me that, oh, look, an API call happened. So what I'm going to do is I'm going to get rid of all the other API calls and trigger a new instance. You should see one call. Nothing super impressive here. That's all good. But let's take a look at how retries happen. If I go back, move all of this a little back, make it real code, and get rid of all of this, and say that I want to randomly, how much time do I have, by the way? 4 minutes? That's plenty. All right. So if I want to say that if I have a maths.random, and in the world of probabilities, if we have the worst luck ever in this room, if an error gets thrown, we'll throw an error. Okay? Now, what should happen in theory is that this should just fail. But because retries work under the hood, like I said previously, it should just work. So let's see if that happens. All right? We're going to go ahead, and this all looks good. Right now, there's a small bug where I need to actually always say that there's a fetch function as well. Pretend like I'm not writing this right now. Okay? Yeah, that didn't happen. But anyway, we'll deploy a new version of this workflow. So I'm going to call npm run workflow, npm run deploy, I'm sorry, because I have a custom version of Wrangler in my package JSON. And it's uploading a script and setting up some metadata and so on. All right, that's done. Now, in theory, that should just fail. Let's see what actually happens. I'm going to create a new instance again, okay? And you see that an API call happened. In fact, a second API call happened. And the reason a second API call happened is presumably because this math.random, through. Of course, the API call was before it. I should have probably put it after to make the point here. But you see how this gets run automatically if something fails. My next demo in a few weeks, I'm actually building it right now, will be about replaying events, and we'll be able to show you the transactionality and atomicity elements, wherein if something now throws within a queue, you would go back and sort of roll back the previous I/O things that you've done, which is really interesting. Now imagine being able to have something like a const map in here. And when I say I/O, by the way, I mean both I/O and compute. But imagine having a const map in here, and imagine doing a map.set to blah is 1, right? You could have it automatically roll back if an error got thrown later. So it's quite literally transactional JavaScript in a sense, right? This is something that most other platforms don't actually do for you today. Of course, there's other fun stuff about this, wherein if you had multiple steps, like you might wonder why multiple steps in the first place, right? If you had multiple steps and if one of them failed, you'll be able to upgrade your code by pushing a bug fix, but resuming from the last step that succeeded. Now that sort of stuff is really valuable when it comes to really expensive compute, as you'd imagine. Finally, I probably have a minute, so I'm going to show you what a RAG would look like. It's quite simple, really. We have access to every binding you could use on workers, on workflows as well. You'd have an event come in. Oh, by the way, events can trigger workflows. That's also upcoming. It's part of this. You'll have events that are both platform-wide as well as user-defined. You'll be able to have your own user events on your Cloudflare stack and have both queues, workers, workflows, readable objects, all of them consume them any way you'd like, right? But in this case, there is an event coming in which is an upload to an R2 bucket. You can probably see that it says put object into my bucket because basically I deploy something and it runs, right? And it runs a workflow, gets the keys, reads the objects from R2, calls some model that I don't even understand. Someone told me to use this model. I don't know if it does anything. It generates embeddings. In this case, it retries exponentially because we know that the AI is flaky and it might, you don't want to put in too much, pressure onto it. And finally, inserts the vectors into this vectorized database that we have, which is a vector database. Now, I already have all of this set up, so I'm going to end this demo by, of course, logging into the dashboard because I didn't do that before. And I'm going to upload a file to R2 for you, and you'll see that the RAG gets run. Now, unfortunately, the cheapest way to show you that the RAG actually ran is to just show you the API response. I mean, I don't really have a consumer of the vectorized instance just yet. But hopefully that should be fun. So let's open R2. I have this documents bucket in here. I'm going to go ahead and upload. I've been uploading absolute random shit in here. So I'll go ahead and upload I don't know, like a bill. I don't even know what bill this is. What the hell is that? Some bill Is it a pay slip? Can you see it? I can't. It's something that I either paid for or that I need to pay for. Oh well, anyway. So we're going to upload that. Now, that's all I've done. I've only uploaded a file to R2, but because of the R2 notification being sent over and the workflow being instantly created, we will be able to list our instances. That workflow is called, I believe it's just called RAG, but honestly, let's find out. We can list our workflows. RAG workflow, there you go. So I'm going to go to RAG workflow and list our instances. And it says error. Interesting. So it didn't like the PDF or whatever I sent it, presumably. But hey, you know what? Sometimes shit fails. It'll work the next time. I'll leave you at that. Yeah, eventually when this is in closed beta, please feel free to play with it. we do believe that this could be a very new and interesting compute model for us on Cloudflare, and we'd love to see what people build with it.
That's awesome. Love a lightning talk. Thanks for showing us the work in progress and in preview. And sorry the demo gods didn't entirely bless you today. Monorepos, that's the way to go.
Yeah.
It was all microservices a while back, but now we're back to monorepos. Looking forward to this talk, and thanks again. Second LNUG talk. Take it away.
Thank you. Well, hello everyone. So thank you for coming here tonight. My talk is going to be about monorepos, and I kind of like to title the talk to be the monorepo survival training. Not that this microphone survived it. But okay, so first things first, a bit about me. So I am a software engineer at Parameter Solutions, and on the side as well, I'm building Noodle, which aims to be kind of a productivity system for students. We grossed over 11,000 GitHub stars actually, and I'm now basically trying to build it. And kind of the main point here is that I like to think of myself as a monorepo enthusiast, and I've built this thing called OrbitKit, which you can see it's a starter kit, but I would actually like to think about it as just a reference for how you can do monorepos, because I just think there is a lot of things that a lot of different guidance around monorepos, and it's kind of hard to know what you should do. You can find me on GitHub and Twitter. It's almost the same username. I just couldn't get the same username on Twitter, so I just added another I. And yeah, so the what and why. Probably everyone here knows what monorepos are, right? Like, hands up if you know what a monorepo is and worked with one. Okay, cool. So a monorepo is basically simply a architecture style that we can use. So instead of splitting every project that we have into its own repository, we can have them all in the same repository. And it kind of looks like this, where you have an apps folder and then a packages folder. It's not like a strict thing that you have to do, but it's what most people do. And the benefits of this is that you can share the code between your different projects. So let's say we have multiple applications and we have one certain UI design system, like a components library that we want every application to use. Instead of like publishing that to NPM, downloading it, and with every code change we need to change the version and download it again to our applications, we can let them all live together, and with one change to the UI package, it kind of radiates to the applications, stuff like that. And at the same time as well, this ensures consistency in our code style, because we can share our lint rules, our formatting, prettier settings, all of that stuff. And so our code will look consistent, and we can also manage versions quite easily as well in monorepos. But this is not really the talk about what's good with monorepos, It's actually what's wrong with them. So if you have ever worked with a monorepo, they are complex. They break often, sometimes, depends how you do it, and they're generally hard to get right, and they're not the easiest thing to maintain either, because a month or two down the road, you can just, start having a weird error, and you spend so much time trying to see what happened there. And for me as well, the most important bit is that monorepos are a subject with not much guidance around them. There is often conflicting information about how you should do something in a monorepo, and do you even know what turborepo or NX are? So yeah, basically all of this just creates challenges that you have to go through to get a monorepo setup working, and on the surface it's like, why should you even do it? And I'm telling you now, you actually should invest the time to do it, because the benefits of it outweigh the costs a lot more. So this is the packages graph in OrbitKit, and it basically says how different packages are all linked together. This is actually using NX for this image, while I'm actually using Turborepo for the Monorepo. But anyways, a line is a direct linkage between two packages. So for example, to kind of make it a bit simpler, if I focus on the web app, you can then see the direct lines, so the dependencies of web in our Monorepo that the web application uses. And this looks fine, but one day we can get to this kind of state where somewhere in some sort of linkage there is an error and it's all now being caught on fire. But obviously you can see that the documentation website is not having errors because it's not linked to anything, right? Because it cannot get on fire. It actually can. Well, with Monorepos as well, you actually need to make sure that the package manager itself is working well. How is it putting your dependencies, the third-party dependencies, in the node modules? What is it hoisting and what is it not? It's a lot of things to kind of take care of. And so with this talk, I'm going to be basically exploring, I would say, 3 of my most important survival tips that you need to take care of while trying to build a Monorepo. So this is an example. Let me just emphasize that the first survival tip is that you should have a consistent tooling configuration setup. And what I mean by that is, let's firstly look at kind of like a problematic example. This is an example that you might have in a Monorepo of a Next.js app's tsconfig, and you can see like it's extending from the tsconfig like back in the root. And on the surface, this looks fine, but it actually does have a problem. And the problem is that you have too many compiler options set in that singular app that you are not syncing these compiler options with anything other than this application. It's a one-off type of option. And you can run into conflicting options if you change something in the package which conflicts with the way the web application is set up. You can run through really hard to debug problems. And so the way basically that I do it in OrbitKit is that I have a folder in the packages folder called config, where I just set configuration presets for every tool that I have in the Monorepo. I have presets for tsconfig, I have a Tailwind preset, so colors, for example, and all of the design system things are radiated through every package, every application. You don't need to set anything. Even Vite configurations, the storybook, and ESLint is a whole another story that we can talk about for days. But once you do this, you come to kind of this place where the only thing that you're setting in your tsconfig is the includes, the excludes, and some paths, because that's relative. But every compiler option is already set up for you. That makes it so that you want a new application, for example, you just copy over, for example, this tsconfig, and you're sure if you change up the next.json preset, every application that's using that same preset is going to have that change. So yeah, now let's go to the second survival tip, and that is you should use internal packages until external ones are needed. And the difference between these kind of two words is that internal packages do not build their TypeScript to JavaScript and before actually shipping them. So literally in the exports we just put our TypeScript source code, which actually works if the way that you're consuming them can do transpiling. Next.js, for example, does that. And external ones are the kind of the typical ones that you might know, which is to build the TypeScript code into JavaScript, create the declaration files, and then you can list that in the exports. Now, internal ones are a lot easier to actually get started with. All you need to do is a package JSON, your TypeScript, and you just put that in your exports and you're good to go. However, at some point in scale, your TypeScript LSP will start complaining. It is a lot faster to actually ship out your declaration files with JavaScript rather than TypeScript source code. So I would say you only use external packages if you want the maximum TypeScript LSP performance, and if you really just care about only handling it when it's needed, you start with internal packages until you get into a slow state of your TypeScript LSP, and then you can try something like that out. And the final survival tip before we go on to the demo is you should spend time to get caching right. What I mean by caching is that in a Monorepo, most of the times we're not changing every package. We're not changing the majority of the code base to need to build a lot of it. We only need to rebuild, the changed aspects of the Monorepo, and we can use something like Turborepo or NX for these kind of tasks. And if you ask me which one should I use, Turborepo or NX, I'll tell you to flip a coin because they're the same. So yeah, basically what they do is that they just never let you run the same task twice, because that is just wasted compute. And yeah, so enough with the slides. I'll now show you an example of a Monorepo, which is going to be OrbitKit. I'll just need to switch my display. Okay, can you see that? Yep, you can. Is it too big? Is that fine? All right, cool. So this is OrbitKit, and we can start, I guess, with the how tooling is configured. So as I said, there is a config folder with a lot of the tooling configurations. So for example, in ESLint, I am simply shipping presets of configuration that are kind of categorized to the technology that they use. So my base one handles, the kind of the basic plugins and TypeScript ESLint. I have a separate Next.js one, and I have a separate Playwright, so on and so forth. And what that lets you to do is, for example, in my UI package, I then have a separate, obviously, ESLint configuration. But all that it does is that it just extends from what it needs to use. So, for example, it extends from base. We're using React for this package, so we extend the React one. We're using Storybook, so we extend from that. And that's all you need to do. It's really simple. There is not much code there is to, set up something complex as ESLint. And so, yeah, another thing is that the way I am doing, for example, compilation or like building the UI package. So this UI package is an entire one-to-one representation of Chatzy and UI. So it has every single primitive that includes. It just switches to Radix UI colors. But I am using TSUB for actually bundling that. And with TSUB, the way I did it is that I actually handle putting in the required exports in the package JSON automatically after build is done. So this bit of code, basically, it grabs from the entry, it figures out what export needs to be there in the package JSON, and it writes it in the package JSON itself. So as you can see here, that's all taken care of, and you don't have to mess around with something like that, because we have, I think, this package has around 56 exports. So you don't need to then manually edit that. It's all taken care of automatically. And now let's talk about kind of the big piece, which is Turborepo. How do you use Turborepo to be, efficient? How do you do it? So then it's, it caches the tasks. And this is the Turborepo that I'm using for this workspace. So I'm actually doing it. For example, the build, it will run the build task of the dependent packages. So let's say the web application is there. It has a dependency over the UI package. Whenever we try to build the web application, it's going to run the build on the UI package beforehand. And as well, like kind of a side thing, it will also run the DB migrations automatically as well. So we set inputs, and what inputs in Turborepo mean is that it will only track these files, and if these files change, it will know that it needs to actually rerun the build. And to show you kind of what Turborepo allows you to do. So if I run the build script here, you can see that it only took 165 milliseconds. That is for the entire workspace. And that is because there has not been any code changes that happened in the workspace for us to actually need to rerun build. And if you can do like -- force, and they will actually build the workspace without caching. But this is what Turborepo allows you to do. And you can see this as well being very beneficial in your CI pipelines, because if you don't need to rebuild everything, your CI pipelines are going to be faster. You can see it's already taking quite a long time. And what's cool about Turborepo as well, and all of these Monorepo caching tools, is let's say I change something only in the web application. So I'm gonna say here like your unique user ID. So like, actually I think I might have a cache in this one, so I'm just gonna get like more ease. So if I do run the build now, let me expand this, you will see that it's actually not building the entire Monorepo. It's only building the application. Now, if we would have changed something in a package, for example, that this application depends on, so let's say if we would have changed something in the UI package, then we would need to rebuild also the application, because we're not sure that that code change in the UI, doesn't change something in the application. So yeah, with this, basically, you're doing the bare minimum to get things working. You're doing, the bare minimum basically to save yourself time. And another really cool thing about this as well is that people in your team can share that cache. So if two people have the same code, then if one person runs build, it's not cached for him. The second person that runs it, even though it's another machine, it will be cached. So they will see the 150 millisecond time, something like that. So yeah, that is kind of the outline of, I guess, Monorepos. Another really cool aspect in kind of this setup is the idea behind handling actually Tailwind and environment variables. I'm going to go over the Tailwind one first. So for Tailwind, how many of you here use Tailwind? Okay, so a good few people. But basically, this entire package is only made for one file. And that's actually not a bad thing. It's in Monorepos, you should split stuff up to packages when it does make sense, and in this case it does. And we're setting colors here, we're setting stuff up, but we don't want to copy this over for every instance that we need to use Tailwind. And so this package is made. There is no build step for this one. It's an internal package that is exporting the TypeScript file. And what's cool about Tailwind specifically is that it's actually using a library called GT, under the hood to load the configuration file, and that doesn't actually need you, it doesn't make it a requirement for you to build the configuration file. And so we just import it from the package and we use it in the presets list, and that's it. If we change a color or anything in that preset, it's radiated to our entire workspace. So yeah, that is kind of the outline of it. The outline of a good Monorepo setup is that if you're copying something and it looks like it is setting something one-off, where if you change it in another place, it's going to act differently if you don't change it, every occurrence of that, then you should split it into a package and you should then import it that way. Because then, as a good source of guidance, if you have one source of truth in a Monorepo, it's going to be fine. If you have to have multiple references to a lot of things and copying and pasting, then it will eventually mismatch and break. And another thing is that I'm also using a package called T3env, which is actually really cool. It checks your environment variables and it also auto-completes it for you. Like, for example, in the web one here, if I start doing env dot, it knows about all of the environment variables that are actually accessible to us. And for the environment variable package, I just export a file per application, and that is what I use in that application reference. So in here, for example, I'm using GT so that I don't have to build that application. Package, sorry. And that's something that you always get mixed up with Monorepos apps and packages. And I'm just using that in the next config, which basically means that this application will not run if the environment variables are invalid. And as well, for the other packages that are internal in Next.js, you need to add it to the transpile packages array, and that takes care of things for you to not need to build the entire thing. So yeah, that is basically that. With Monorepos, there is so much that you can talk about. It's a very large topic, but I hope that with this I kind of give you a kind of an outlook on how I would say a good Monorepo setup looks like. But yeah, I think that is all. I think then I need another. Oh yeah. So that is pretty much it. Thank you. I think you can check out OrbitKit at orbitkit.dev, and also if you're interested as well for Noodle, my other project, and me on Twitter and GitHub. But yeah, thank you all.
Thank you.
If you have any questions, I guess.
Any questions?
Hi, you said the Monorepo provide a good concept of like sharing the cache between different users or like different developers.
Yeah.
But how do you do that in different? Let's say there is a pipeline which is running in a master branch. There is a pipeline that is running in a feature branch, and in the feature branch I want to use the cache which was built previously in the master branch.
Yes.
How can I share it? Because sometimes I use Monorepo, and one thing that I noticed is to store that cache somewhere, because the cache size is so much huge. To upload the cache and to download the cache itself takes like lots of time.
So the way that I do it is I just set the Turbo team and Turbo API key from Vercel, and I let them handle that. So they are the ones, like you will see in here. Let me show you. So you'll see, for example, if I do turbo build, it should be that at the very start of the script itself, it will tell you if remote caching is enabled or not. Now, this is So for example here, remote caching is disabled because I don't have these environment variables set on the laptop. But in my CI pipeline, it actually says that they are enabled. So once a pull request is done and it has been merged, now it's the same version on master as that PR, and so the caching works, and the pipeline for masters after, like the main branch, after you merge that pull request, it's just super quick because it doesn't need to rebuild anything. So yeah.
So you're saying like a turbo out of the box kind of
yes,
saves the latest cache and download the cache.
Yeah. You literally just need to set 2 environment variables, and that's it. It takes care of the caching for you, like remotely. Yeah.
Okay. Thank you.
Yeah. Thank you. Any other
Thank
questions?
you. There's one in the back there as well.
I think you mentioned package hoisting in passing. How do you choose when to? I assume that means you have a package JSON at the top level and in each of the packages.
Yes. So I do have a root package JSON.
The question was going to be, how do you choose? How do you personally choose what to put in your top level package JSON versus?
Like what dependencies come into the root package?
Yeah, like
JSON,
would you hoist
right?
TypeScript or your pretty own
Yes.
ESLint?
So I will show you here. For example, I am setting like ESLint as a dev dependency in my root, and also prettier, because for me, I only have my prettier config in the root level. I'm not having a different prettier config, per package. You don't actually want to do that. Like, you want to have the same styles for everything. And I am also setting TypeScript as a dependency of root, so then that way every package is using the same, TypeScript version.
So they tend to be your dev dependencies, not your runtime dependencies.
Yes, if you're having a dependency that goes into production in your root package JSON, there's probably something wrong going there.
Thanks.
Yeah. All right.
Okay, I think we're going to call it time because it is time.
Right. Thank you, everyone.
Thanks a lot, Ahmed. So you've heard it all tonight, from monorepos to cloud work step things without a name, and the full stack with TypeScript. Thanks for a great evening. It's not over yet. If you follow Sid, the Pied Piper, he's going to the pub, and he knows which one to go to. The Lower Marsh, it's called, I think, is it?
It's called Draft.
Draft. It's in Lower Marsh Road. Yeah, okay.
Yes, that's the one.
Yeah. All right, well, a few of us know where it is, so we can lead the way for a drink on the way home. Thanks all for coming. Hopefully we'll get another one in soon, next month maybe. We've got a couple of talks, potential talks. Thomas has very important information about how to actually leave the building, so don't go.